Representing fractions 1, misconception 1. Students with misconception 1, part to whole, unequal pieces, consistently associate the number of shaded pieces with the numerator and the total number of pieces with the denominator. They do not pay attention to the size of the pieces. We will take a look at 3 similar items and student thinking about the 3 items to gain a better understanding of misconception 1. All of the items we will explore are contiguous, meaning all of the shaded pieces in each figure will share common borders, and all of the unshaded pieces will share common borders as well. In each item, there will be unequal portioning, and students will need to consider the size of the pieces or region in each item to determine the answer. In the first example, when asked if the shaded area in the problem was 2/5, student A answered no. Student A redrew the figure, divided the figure into 5 equal sections, and shaded in 2. Then student A said the real 2/5 of this shape. This explanation provides some evidence the student considered the size of the pieces or region when choosing an answer. Student B selected yes for an answer and then explained, I chose this answer because 2 parts of 5 is shaded. From this explanation, we can infer the student counted the shaded in pieces for the numerator and the total number of pieces for the denominator, but the student did not pay attention to the size of the pieces. This is an example of misconception 1. In the second example is the shaded part 1/3. We see that student A chose no, and then provided us with two drawings to explain the thinking behind that response. In the first drawing, the student redrew the original figure, shading in that small section at the bottom, and said 1/3 incorrect. In the second figure, the student redrew the figure, dividing it into 3 equal-sized pieces, shading in one of them and saying 1/3 correct. These drawings give us a pretty good indication that the student was thinking about the size of the pieces as they were determining the answer to the question. Student B chose yes for an answer and then explained by saying, I first checked to see if there were 3 pieces. So the student was counting up the total number of pieces. The student continued on to say, there were, so I checked to see if there was 1 shaded in. So going over and checking that 1 shaded in. There was, so the answer is yes. So this is a clear example of misconception 1. The student counted up the total number of pieces as the denominator, counted the shaded in piece as the numerator, but did not consider the size of the pieces when trying to solve this problem. In the final item, let's look closely at the thinking behind the student's responses. In example A, the student chose the answer no. Then the student redrew the figure, dividing it into 4 equal pieces, numbering the 4 pieces, and shading in one of those 4 pieces. The student then indicated that that 1 piece equaled 1/4. The student then went on to explain the pieces are not divided evenly. All of this evidence suggests that the student was considering the size of the pieces when determining an answer. Student B chose the response yes, then redrew the figure pretty much as it was, shading in that one small piece, labeling it as one shaded, indicating that there are 3 blank pieces, adding the one shaded and the 3 blank pieces to get a total of 4 pieces. So in fact, this is a great example of misconception 1. The student took the one shaded in piece and counted it for the numerator. The 4 pieces total, counted it for the denominator, but the student didn't consider the size of the pieces when trying to determine an answer.